Yes.
As I got ready for church this morning, a song kept coming to me. Red, right here, so you see clearly. So imagine this is a rhombus, right?
Today's class. Welcome, welcome, welcome. Thank you for joining the live class. I'm so glad to have you here. Today is a repeat of yesterday's class. We had some technical issues, so we are repeating yesterday's class. So we are looking at indices today. The topic we are looking at is indices. Okay, just give me a minute. We are about to start. Okay, so let's go ahead. Welcome everybody. Please help me tap on the screen so that more persons can join the live session. Thank you. Okay, so the way I teach is when we start a new topic, I like to explain what the topic is or define the topic so that you have a foundation for every other thing that we're going to be doing in the class. Okay. So the first thing we need to ask ourselves is what is indices or what is an index number? Because the word indices is gotten from the word index. So indices is a plural of index. So if you understand what index is, then you understand what indices is. So a number is said to be in index form when it multiplies itself lots of times. So you can say that a number is in index form when that number multiplies itself lots of times. Okay, so when you see a number multiplying itself, then that number can be written in index form. For example, if you have t to the power of 3, t to the power of 3, t to the power of 3 is same thing as t multiplied by t multiplied by t. So t to the power of 3 simply means t is multiplying itself 3 times. So remember, a number is said to be in index form when it multiplies itself lots of times or a number of times. So here t is multiplying itself 1, 2, 3 times. So since t is multiplying itself 3 times, we can write t in index form. So this is the index form of this multiplication of t. So since t is multiplying itself 3 times, t can be written in index form, t to the power of 3, right? So when you have a number in index form, an index number is made up of two numbers. Let's use, for example, 2 to the power of 3. Okay, let's use 2 to the power of 3 as an example. This is an index number, or this is an indices. But since it is just one value, we can call it an index number. So this number at the top is called the power or the exponent. The number at the top is called the power or the exponent. So this is important as we go further. It will come in handy. So you should know which one is the exponent or power and which one is the base. So one is the exponent or power, the other is the base. But together, they are called index number. Together, they are called index number. But this one on top is called the power, and this one at the bottom is called the base. Together, they are called index numbers. Okay? So going further, we're going to be looking at the laws of indices. Okay? The laws that apply to numbers in this form. When you are multiplying them, when you are dividing them, and so on. We're going to see those laws. Thank you for tapping on the screen. I'm so grateful. Thank you so much. Okay, so just give me a minute. Let me check on those on YouTube. 1 minute. Okay, so now we'll go further by looking at the different laws of indices. Different laws of indices. So remember, laws of indices govern the multiplication, addition, subtraction, division of index numbers. So in today's class, we are going to be looking at 4 laws of indices. In tomorrow's class, we are going to continue by looking at the rest of the laws of indices. Okay? One minute. Please give me 1 minute. Sorry about that. Okay, so the first law of indices we are going to be looking at is the addition law. So the first law we are looking at today is the addition law. The addition law. Okay. The addition law states that when you are multiplying two index numbers with the same base, all you need to do is add the powers or add the exponents. When you are multiplying two index numbers with the same base, all you need to do is add the exponents. So all you need to do is add the exponents or the power. So when you are multiplying two index numbers with the same base, all you need to do is add the exponents. Remember what the base of an index number is, and also remember what the power or exponent of an index number is. Okay, so if we have something like this, 2 to the power of 4 times 2 to the power of 3, 2 to the power of 4 times 2 to the power of 3. If you look at this, the base here is 2, the power here is 4. The base here is 2, the power here is 3. So from this, we can observe that the bases are the same. So since the bases are the same, we can obey this law. But if we have something in this form, 2 to the power of 4 times 3 to the power of 2. For example, if we have this situation, we cannot apply this law. Why can't we apply this law? Correct. Angela was, I think you were here yesterday. I have to repeat the live because the YouTube viewers were disconnected, so I had to just repeat the live class. Okay, so here the bases are the same, but here the bases are different. So since here the bases are different, you cannot apply this addition rule, because for you to apply the addition rule, the bases have to be the same. So you can't apply it here. But over here, we can see that the bases are the same. Therefore, we can follow this rule. This rule states that when you are multiplying two index numbers with the same base, simply add the exponent. So this is going to be, you pick one of the two bases, and then you do 4 plus 3. And that will give you 2 to the power of 7, as Angela said. Okay. So let's continue. Let's continue. Hello, Abena. Nice to have you in the live class. Thank you so much for the gift. Let's continue. Let's look at some examples using this law. Let's apply some examples. So I'm going to write this, or let me just try to use this point. Okay. Okay, so if we have b to the power of 5 times b to the power of 2. Let's see why this law is correct. Remember, an index number shows that the base is multiplying itself a couple of times or a number of times. So if you have b to the power of 5 times b to the power of 2, this simply means, let's split this into 2. We know that b to the power of 5, since the bases are the same b. So this is b to the power of 5 plus 2, which will give you b to the power of 7. That's correct. But let's see why it is correct. If you write b to the power of 5, b to the power of 5 means that b is multiplying itself 5 times. So b times b times b times b times b. This shows b to the power of 5. This shows b to the power of 5. Then times b to the power of 2. b to the power of 2 means b is multiplying itself 2 times. So times b times b. So b to the power of 5 is from here to here. B to the power of 2 is from here to here. So, but since they are all multiplying themselves, and the power of an index number tells you how many times a number is multiplying itself, you can just count 1, 2, 3, 4, 5, 6, 7. That also gives you b to the power of 7. So this confirms that this process is accurate. Okay. So let's continue. Let's look at other examples. Okay. So if we have 6x to the power of 4 times 2x to the power of 3. 6x to the power of 4 times 2x to the power of 3. We want to multiply these two index numbers. So when you have this situation where you have a coefficient, remember a coefficient is the number in front of the variable, in front of the alphabet. So when you have a situation like this, what you do to make your work easy is bring the numbers together, put them in one bracket. So this can be 6 times 2 in one bracket, since they are both numbers, and then the alphabets, you put them in one bracket. X to the power of 4 times x to the power of 3. Okay, so this makes your work easier. So you can simply multiply the numbers. 6 times 2 gives you, sorry, this is 3. 6 times 3 gives you 18. So you have 18 here. And then you can apply the addition rule or the addition law. The bases here are the same, so you can add the powers. So this will give you x to the power of 4 plus 3. X to the power of 4 plus 3. Thank you for the likes. Please, let's try to get the likes to 5,000 likes. Oh, thank you. I was considering this 2 there, this 2. Thank you. So you have 2 here. So 6 times 2 gives you 12. Okay. Okay. So now you can just simply do 12x to the power of 6 plus 3 gives you 7. And that becomes 4 plus 3 gives you 7. And that becomes the answer. Okay. Thank you for the correction. I was initially looking at this 3 here. Okay. Okay, thank you. So let's look at another example. Let's look at another example. So if you have okay. So if you have a situation like this, 4x to the power of 3, y to the power of 2 times 6x, y to the power of 3. So just as we did in the first example, we bring similar terms into one bracket, okay, into different brackets. So here, the numbers are 4 and 6. So we can put 4 and 6 in one bracket and multiply them. So we're going to have 4 times 6. And then we have x here, we have x here. We can also put x in one bracket. So we have x to the power of 3 times x to the power of. What is the power of x over here? What is the power of x over here? Who can tell us the power of x over here? Who can tell us the power of x over here? 1. Since there is no exponent here, since there is no power here, you should have it at the back of your mind that the power there is an invisible one. So when there is no power visible there, know that the power is 1. So let's write it. And then in another bracket, y to the power of 3 or 2 times y to the power of 3. Okay. Okay, so with this, we can multiply the numbers. So the numbers are easy to multiply. 4 times 6 gives you 24. So you've gotten the value for the number. Then you look at x. Here, the bases are the same, so you add the power. So you have x 3 plus 1. And then you go to y, the bases are also the same, so you have y 2 plus 3. Okay? And then finally, our answer is going to be 24. 3 plus 1 gives us 4, so we have x to the power of 4. And then 2 plus 3 gives us 5, so we have y to the power of 5. So we have applied the addition law in solving this question. Remember, the topic is indices. We are looking at the laws of indices. So we have just looked at the first law of indices, which is the addition law. I come live every Wednesday and Friday. Today, I just had to do a repeat of yesterday's class because my students on YouTube were disconnected. So I had to just do a repeat of the class. Okay, so I'm going to give you guys some questions to solve before we continue with the class. So let me wipe this off. Okay, on Wednesdays, I come live 8 p.m. Nigerian time, 8 p.m. Nigerian time. And on Fridays also 8 p.m. Nigerian time. 8 p.m. Nigerian time is 7 p.m. Ghanaian time. I think it's about 10 p.m. or 9 p.m. South African time. 9:37 from Jamaica. Oh, I think, what's the time over there in Jamaica? Tell me the time and then I'll tell you how many hours behind you are from us. Or how many hours we are ahead of you. Okay, the time over here is 9:37. This class is not strictly for WAEC, but if you follow with the class, PM is PM. Yeah. Okay, 6 hours, 2 p.m. your time. No, we are 6 hours ahead of you. We are 6 hours ahead of you. So that means 8 p.m. my time will be 2 p.m. your time in Jamaica. Yeah. So you guys should try this out and let me know the answer. Yeah, you guys should try this question. In 2 minutes, 2 minutes, I'd like to get, or 3 minutes, I'd like to get the answer so we can continue. 3 minutes. Yeah, 28 power of 5. Are you trying to say 28 to the power of 5? You are missing out something. For the first question, you are missing out something here. 28y to the power of 5, okay? 28y to the power of 5. Can any other person confirm the answer? 28y to the power of 5. Please tap on the screen so I can get to 5,000 likes. Please tap on the screen so that I can get to 5,000 likes. Please tap on the screen so that I can get to 5,000 likes. Okay, so let's continue. Yeah, has anybody gotten this answer to the second question? Anybody gotten the answer to the second question? One minute more, 1 minute more. Yeah, that's the answer to the first question. That's the answer to the first question. 226. Okay, 6. Okay, number 2, 6u to the power of 4. Is u to the power of 4? Yeah, you're correct. V is to the power of 6, but it's u to the power of 4. It's u to the power of 4. What's the exponent of u here? What's the power of u here? Over here, u has a power. Though you can't see it, but u has a power there. 1, okay? So if u has a power of 1 here, and u has a power of 4 here, so what will be the power of u in the answer? Yeah, somebody said he or she is lost. U to the power of 5, correct? So 6u to the power of 5, v to the power of 5, correct? Okay, very good, very good, very good. Thank you everyone for participating. Some are solving, some are liking, some are looking. Everyone is doing one thing or the other. Okay, very good. So let's continue. Let's go to the second law. Okay, u to the power of 5. Let's go to the second law. So we've looked at the first law. The first law of indices we've looked at is the addition law. The second law of indices we're going to be looking at is the subtraction law. So for the subtraction law, when you are dividing index numbers with the same base, subtract the second power from the first power. Okay, so this is what the law simply states. When you are dividing two when you are dividing index numbers with the same base, subtract the second power from the first. So if you have a to the power of b divided by a to the power of c, a to the power of b divided by a to the power of c. Over here, we can see that the bases are the same. Bases are a. So when the bases are the same, all you need to do is subtract the second power from the first power. So what you're going to have is a to the power of b minus c, whatever it is, whatever number uh, is allocated that position. A to the power of b divided by a to the power of c is the same thing as a to the power of b minus c. Okay. So we're going to look at some examples. Yeah, we're going to see why. We're going to see why. We're going to see why. We're going to see why that is the case, and then we're going to look at more examples. Okay, let's continue by answering why. Let's see why. So I'm going to wipe this off so we can answer the question why. Let's say we have example. Let's say we have y to the power of 6 divided by y to the power of 2. So this law states that when the bases are the same, subtract the second power from the first power. So this would be y to the power of 6 minus 2. And 6 minus 2 is equal to 4. So we have y to the power of 4. Now, let's see why this is the case. From the beginning, we say that y to the power of 6 means y is multiplying itself 6 times. So let's do that. Y times y times y. So this is the same thing as y to the power of 6. Y is multiplying itself 6 times, but it is divided by y to the power of 2. So divided by y to the power of 2. Y to the power of 2 means y is dividing itself, y is multiplying itself 2 times. So we have y times y. Okay, so remember we are dividing, and when the same value appears in the numerator and denominator, you can cancel them out. Yeah, that's why I'm explaining, that's why I'm showing you why it is minus. Okay, it's the process of getting the answer. So here is y to the power of 6, which is y times y times y 6 times, and here is y multiplying itself 2 times. So at this point, the first y can cancel out this first y. The second y can cancel out this second y. At the end of the day, we have 1, 2, 3, 4 y's, which is the same thing as y to the power of 4, which agrees with this. Okay, so yeah, we said earlier, and we wrote down that when dividing index numbers with the same base, the law is clear about that. With the same base. So for you to apply this law, the basis must be the same. For you to apply this law, the basis must be the same. So if the bases are not the same, then you cannot apply the law. If the bases are not the same, you cannot apply the law. So let's look at some examples. Let's look at some examples. Okay. Okay. So if you have 18x to the power of 7 divided by 3x to the power of 2. 18x to the power of 7 divided by 3x to the power of 2. Law is subtraction law. So just as we did in the previous example, the numbers, you bring the numbers and put them in one bracket. Put them in one bracket to make your work easy. So you have 18 divided by 3. Since they are both numbers, put them in one bracket. Then the variables, put them in one bracket. X to the power of 7 divided by x to the power of 2. X to the power of 7 divided by x to the power of 2. Okay, good. I'm glad you understand it now. What class am I taking? Do you mean the topic I'm taking or what class I teach? My focus is basically high school maths, which is the most important mathematics you need. So I don't teach calculus and university mathematics because not everybody needs that. But basic mathematics, especially geometry, arithmetic, I teach those topics because almost everybody needs that. Okay. So 18 divided by 3 gives us 6. And then we have x to the power of 7 divided by x to the power of 2. The bases are the same, therefore we subtract the second power from the first one. So this would be 6 to the power of 6x to the power of 5. So that becomes the answer. 6x to the power of 5. 6x to the power of 5. You can join my WhatsApp group. Partial derivative, and I don't teach that. I don't teach that because those topics are not basic maths topics. Differentiation, integration, I don't teach that. The reason is not many people might end up applying those things. So yeah, there are online tutors that teach those topics, but I don't focus on that. I focus on some advanced topics. Not many persons will benefit from it. So I won't be able to do all things, so I pick something that I definitely do that. Okay, so let's look at another example. So we have 12x to the power of 4, y to the power of 3, divided by 3x to the power of 2y. C times C. Different countries have different terms, so I don't understand what C times C mean. Thank you too. As I said earlier, I come live every Wednesday and Friday. Today is an exception. I come live Wednesday and Friday. If you miss my live class, you can go to my YouTube channel to watch a replay of it. So I post the replay of my live class on my YouTube channel. Also, I have some students that are watching right now on YouTube. You can join my WhatsApp group too. The link is on my bio. If you want to join my WhatsApp group, you can go to the link on my bio and click there, and my assistant will add you to the group. Okay, so we have 12x to the power of 4, y to the power of 3, divided by 3x to the power of 2y. Okay, so just as we did, we bring like terms into the same bracket. So the numbers, we bring them to the same bracket. 12 divided by 3. And then we bring the x values to the same bracket. Y has an invisible exponent of 1. So, yeah, correct. So 12 divided by 3 gives you 4. Here, the bases are the same, so you subtract the second exponent from the first. So we have x to the power of 4 minus 2. And here you do the same, the bases are the same, so you subtract 1 from 3. Y to the power of 3 minus 1. Please, can you help me tap on the screen? So 10K likes, 10K likes. So this gives us y, sorry, 4x, 4 minus 2 gives us 2, 3 minus 1 gives us 2. So we have 4y to the power of 4x to the power of 2, y to the power of 2. Thank you so much for your support, your like, your comment, your participation, your gift. Thank you for the gift. Believer, thank you. This kid, Fred, thank you so much. I really appreciate. Mind you, every gift I get is, once I can get it out, is for my students, uh, the students I teach physically. Okay, so, but there's no pressure for anybody to give. But once I can get the cash equivalent, as time goes on, I'll always give it to my students because I teach a public school that is, I meet children that are come from very poor backgrounds. So I think that's a way of giving back to them. Okay, let's look at classwork. I'd like you guys to solve this question. Yeah, I'd like to see the answer to I'm looking forward to see the answer to the second question. Yeah, the first one, very easy, correct? Correct. Thank you so much, Kelsey Love. Thank you for joining. Thank you for being here. I'm going to try to, at the end of the live class, I'm going to try to follow all the persons that at least commented during the live session. Okay, so we've gotten the answer to the first one, 5x to the power of 4, correct? What about the second question? Two B, 2AB, 2AB, 2AB. Let's see. Okay, B, A to the power of 1. Okay, B to the power of minus 2. Okay, 2A to the power of 2. How did you get A to the power of 2? Your B is correct. B to the power of minus 2 is correct. But this a here has an invisible exponent of 1. So there's actually a 1 here, an exponent of 1, invisible exponent there. Thank, thank you everyone on YouTube. Thank you so much. Thank you so much for your time. Sorry, let me arrange this. Those on YouTube, you can't see. You can't see. Wow. So sorry about that. Those persons on YouTube, the students on YouTube. I'm so sorry about that. I didn't know you guys weren't seeing. The YouTube network is so bad. I'm so sorry about the situation back here. Thank you so much for the 10K likes. Thank you so much. I need to get a second phone so I can know what's happening on YouTube. The network is pretty bad on YouTube. Okay, okay. Sorry about the poor network over there. And that was the reason I had to repeat the class. Okay, so let's continue. So let's look at the third law for today. So this next law is very easy. This next law is the zero index law. Zero index law. This law states that any number that is raised to the power of 0 is equal to 1. Any number raised to the power of 0 is equal to 1. So this law states that any number, any number at all, with an exponent or a power of 0 is equal to 1. That's what this law states. So it means that a to the power of 0 is equal to 1. So a represents any number at all. Any number to the power of 0 is equal to 1. Any number to the power of 0 is equal to 1. For those on YouTube, please, by our next class, which is tomorrow, I will get a second phone that I will use to be monitoring what's happening over there. So let's prove what I mean. Okay, I think I've come up with something that can be of help. Okay, so let's prove what I mean. Let's prove what I mean. So let's prove what I mean. So this means that 2 to the power of 0 is equal to 1. 2 to the power of 0 is equal to 1. 2 to the power of 0 is equal to 1. 2 to the power of 0 is equal to 1. Okay, let's see that. Let's prove it. Let's prove it. So if I have 2 to the power of 0, 2 to the power of 0 is the same thing as 2 to the power of, can we write it as, or before we do that, 0 is the same thing as 1 minus 1. Do we agree? 0 is the same thing as 1 minus 1. It's also the same thing as 0 is also the same thing as 2 minus 2. 0 is the same thing as 2. So 0 is the same thing as 1 minus 1. Any number subtracting itself will give you 0. Any number subtracting itself will give you 0. 0 is the same thing as 100 minus 100. It will give you 0. Right? So instead of having 2 to the power of 0, we can replace it with a number subtracting itself. We can replace it with a number subtracting itself. So we can have, this is the same thing as 2 to the power of 2 minus 2. This is the same thing as 2 minus 2 will give you 0. So we have not changed what we have. It's the same thing. 2 to the power of 0 is the same thing as 2 to the power of 2 minus 2. It's the same thing. It's the same thing as 2 to the power of 4 minus 4. It's the same thing as 2 to the power of 10 minus 10. Nothing. But here we can see the subtraction rule in play. This is the subtraction rule in play. Remember, when you have two index numbers, you can subtract the second exponent from the first. So this is the same thing as 2 to the power of 2 divided by 2 to the power of 2. Does anybody agree? If you agree, can I see your comment in the comment section? If you agree that these things are, if you agree that it's the same, let me see your comment. Yeah. Students from YouTube. Kelly K said, agree. Okay. Good. So this and this are the same. Initially, when we are solving using the subtraction rule, we are moving from here to here. When we have something like this, we'll convert it to this. But now we are moving from this to this. Okay. We're just trying to prove what we have here. So let's look at this closely. 2 to the power of 2 is the same thing as 4, divided by 2 to the power of 2 is the same thing as 4. And 4 divided by 4 is going to give you 1. 4 divided by 4 is going to give you 1. So if you use any number to do this, you end up with 1. If you use any number at all to do this, you will end up with 1. Yeah, I think those from YouTube, it seems to be clearer when you are watching the replay of the live session than when you are participating in the live session itself. That's what I observed. The live session is not usually clear, but when you watch the replay, it becomes clear. So probably that's what we'll be doing in our class. I'll make the live session on TikTok and then also have a phone recording it on YouTube. Then after the class, you guys can go watch the live because it will be clearer after the class itself. Okay. So let's continue. Let's continue. So now we've proven that any number to the power of 0 will be equal to 1. Right? So now let's solve one question. This one, we just need to solve one question. Okay. Thank you everyone for being around, for sticking around till this point. I'm so glad you're still here. Okay, so if we have example, three b to the power of 4 times 4y to the power of 0. Can anybody attempt it before I solve it? In 2 minutes, can anybody attempt it before I solve it? Those of you on TikTok, can anybody attempt it before I solve? Just 1 minute. Can anybody give us the answer in 1 minute before I solve? Forty seconds more. 30 seconds more. Is there any champion in the house? 3b to the power of 4. 3b to the power of 4. Okay. 13yb to the power of 4. Okay. Good attempt. Good attempt. Einstein, good attempt. Gets, I can't pronounce it, that's a good attempt. Yeah, I didn't say you got it. Good attempt. 12by to the power of 4. Okay, okay, okay. You guys all did well. 12b to the power of 4. 12b. Einstein. I think you are Einstein yourself. 4b to the power of 4. Okay, you guys did well. So just as we've been doing before, you bring the numbers together. 3 times 4. And then you bring the variables together, b to the power of 4 times y to the power of 0. So multiplying these two, we have 12. Going over here, for us to apply the addition rule here, the bases must be the same. But looking at this, you can see that the bases are not the same. Looking at this, you can see that the bases are not the same. Okay? So we cannot apply the addition rule. But if we observe here, we have y to the power of 0. And any number to the power of 0 is equal to 1. That means y to the power of 0 is the same thing as 1. So we can have b to the power of 4 times 1, because this is 1. So this will give us 12. Anything times 1 will give you that. So we have 12b to the power of 4. And that becomes our answer. Please, while you guys are writing, give me 1 minute. Sorry, I had to respond to a message. Okay. So let's look at the last one. Let's look at the last one. So the last law we're going to look at for today Okay, so look at the product law. Thank you for your participation in today's class. Those on YouTube, those on TikTok, I'm so glad you're here. If you're on TikTok and you want to join my WhatsApp group, you can simply go to my bio, click the link on my bio, and then you see an option that gives you access to my WhatsApp group. You can join, and then we also have an interactive class where students can help each other out with the assignment. So if you are finding any assignment difficult, if you post it on that interactive class, you might find out that a student somewhere in the world knows that topic and can explain it to you. Okay? So this product law states that when raising an expression having a power to another power, keep the base and multiply the powers. Keep the base and multiply the powers. I'm so sorry about the network condition of YouTube. So sorry about that. It's really poor. Really, really, really poor. But I'll try to make sure that in our next class, I'll repost the one I have on TikTok on YouTube so that the quality will be better. Okay, so this means a to the power of b multiplied by c. So when you have a value like this, a to the power of b, a has an exponent of b, and then this entire expression is raised to the power of c. In this situation, all you need to do is you have a to the power of b times c, which will give you a to the power of bc. A to the power of bc. Okay, so let's quickly solve some questions because time is running out and I need to have a class. Okay, let's solve an example. Let's look at this example. Simplify 3 to the power of 5 raised to the power of 3. 3 to the power of 5 raised to the power of 3. 3 to the power of 5 raised to the power of 3. So can we take the likes to 15,000 likes? 15,000 likes. Let's go. 15,000 likes on TikTok. So here, using this law, this product law, since one exponent, you have another exponent. So this is simply going to be 3 to the power of 5 times 3. And that will give us 3 to the power of 15. 3 to the power of 15. Great job, guys. Great job, guys. Thank you so much. Let's look at another example. I need to wipe this out. Let's simplify 3 to the power of m squared to the power of 3. Yeah. Before we go ahead to solve this, can someone tell me the answer? If you know the answer to this, can you tell me the answer before we solve? Twenty-seven m to the power of 6. 27 m to the power of 6. Einstein is doing a good job. Einstein is doing a good job. Okay. Let's solve. Let's see it. So this exponent belongs to everything in this parenthesis. This exponent belongs to all the values in this parenthesis. Very important. So every value in this parenthesis partakes of this exponent of 3. So this means 3 is going to partake of it and m is going to partake of it. Now 3 has an exponent already. 3 has an exponent. The exponent of 3 is 1. So this will be 3 to the power of 1, n to the power of 2 raised to the power of 3. The exponent of 3 is 1. There's an invisible, every number has an exponent. So when the exponent is 1, there's no need to write the exponent. So now going forward, this 3 is going to be multiplied by the exponent of 3, and this 3 is going to be multiplied by the exponent of n. So we're going to have 3 to the power of 1 times 3. We've ended the life. Please, those on YouTube, give me a minute. TikTok again, Thomas. Continue. Get up the music. Sorry, I'll be back. Those are YouTube. I was, the live class on TikTok was just abruptly ended. Please give me a minute. I'm almost done. Okay. Sorry about that. The TikTok class just ended abruptly. Okay. So back to what we are doing. So we have 3 to the power of 1 times 2, and then m to the power of 2 times 3. Because this external exponent is going to be shared by both 3 and m. So 3 to the power of 3 and m to the power of 6. Okay. So 3 to the power of 3 means 3 multiplying itself 3 times. 3 to the power of 3 means 3 is multiplying itself 3 times. So this will give us 3 times 3, 9. 9 times 3, 27. So we have 27 m to the power of 6. 27 m to the power of 6. 27 m to the power of 6. Yeah, Emanuela, is it the live ended on TikTok or on YouTube? Which one are you talking about? I know the live has ended on TikTok, but I restarted it. I don't know. Once I get to about an hour, TikTok will just automatically disconnect me. Okay, so let's look at one more question before we call it a day for tonight. Or before we call it a night. It's already night, not a day. So we have the last one. Simplify 3 parentheses d to the power of 3 raised to the power of 4. Masamba, nice to see you. Okay, so let's see this question quickly before we go. So 3 e to the power of 3 to the power of 4. Now, this 4 is owned by the values in the parentheses. This exponent of 4 does not affect 3 because 3 is not part of the parentheses. Yeah, King, nice to meet you. How is Namibia today? So the values in this parentheses are the only values that are influenced by 4. 3 is not influenced by 4. So it is important to take note of that. And also remember, D has an exponent of 1. D has an exponent of 1. So this will give us 3 parentheses, D to the power of 1, E to the power of 3, 4. And then this 4 is going to multiply the exponent of D, and this 4 is going to multiply the exponent of E. So this will be okay. Namibia is cold today. I wish I lived there. I need somewhere that is cold. I need somewhere that is very cold. Okay, so D to the power of 1 times 4. 1 times 4 will give us 4. So we'll have 3D to the power of 4, E to the power of 12. That becomes our answer. That becomes our answer. It's raining. Oh, I thought Namibia is a desert. Okay, once in a while it rains in desert environments too. No, the little I know about Namibia, I think Namibia is a desert country. Yeah, I can do sword, but it's not in my power to choose the topic I am going to teach. The students in my group, my WhatsApp group, they are the ones that decide the topic that we're going to learn. So that means if you want to choose the topic we're going to learn, you'll be part of the voting system for next week, because the topic we are learning now was actually voted for in my WhatsApp group. Okay. So the majority carries the vote. So what the majority of the group wants, that's what I will teach for that particular week. The link to join my WhatsApp group is in my bio. But if you go to my bio, you can't find the link. You can just send me a DM stating that you were in my live class, and then you couldn't find the link. That's if you go to the bio and I can't find the link. Then if you do that, I will and drop your number, then I will add you to the WhatsApp group. And my WhatsApp phone number, no, I can't do that online. It's not right. My WhatsApp, as I said earlier, the link to my WhatsApp group is on my bio. You go to my bio, that's what you can see on the screen. You can see my name there, Agbani Maths Academy, and the picture. Once you click on it, it will take you to my profile. Once you click on my picture, it take you to my profile. Then from there, you see the link. If you can't find the link, then send me a DM telling me that you were in a live class and then you wanted to join the WhatsApp group, but you can't find the link. And then you drop your phone number, and then I'll add you to the WhatsApp group. Okay, so I think that is the last question that we're going to solve for today. But I'll leave you guys with an assignment. In my WhatsApp group, you have the opportunity to get assignment on. You can't find the bio, you can't find my profile. you can see at the top of your screen, you see Agbani Max, you see option to follow, you see my picture, you click on that, then click the picture you see there, it will take you to my profile. On my profile, you see some some things I wrote down, and then you see the link there. You see the link. When you see a link, you will know, right? Just click on the link. But if you can't do that, send me a DM. That's just the summary of it. Okay, so I'll leave you with this assignment. This is especially for my students in my WhatsApp group. You can get the assignment done and then submit it to the class coordinator. In my WhatsApp group, there is a class coordinator, a lady there who will accept who will accept your assignment, check it, and take record of your performance. So the best students will attract some gifts at the end of each month. So the classwork, simplify. Also, if you're just joining me on WhatsApp, thank you so much, Kwasi. If you are joining me, just joining on WhatsApp, and then you want to watch the entire video, entire live class, you can go to my YouTube channel, Agbani Mass Academy. I upload every live class I have on YouTube, so you can watch it at any time you like. So what I'm trying to do, I'm trying to create a free library of math topics on YouTube. You can refer your friends, your students, your children to go and watch it for free. It's a detailed class. Okay. So you have four. So for you to solve this, you're going to apply at least 2 of the laws that we have learned today. So be careful. As I said earlier, for you to solve this, can I add you to my WhatsApp? Is it your account WhatsApp group? Yeah, for you to join the WhatsApp group, you need to send me a DM. You need to send me a DM. Okay. I think I should write it as assignment, not just classwork. Yeah, in my country, we call it assignment. What you have to do on your own after the class. Okay. Okay, I will reply to your text, Leah. Thank you. Okay, so with this, we've come to the end of today's class. We'll continue tomorrow, 8 p.m. Nigerian time. Those on YouTube, thank you so much for joining and remaining for this long. But if you find if YouTube is not clear enough for you, I know the persons that are on YouTube are from the WhatsApp group. So if YouTube is not clear enough, from tomorrow, I'll be posting the link to the WhatsApp live class. Instead of going to YouTube, we'll go to WhatsApp. Then those that missed the WhatsApp, not WhatsApp, the TikTok, sorry. I'll be posting the link to the TikTok live on the platform. Then those that missed the live can watch it whenever they are available on YouTube. That's how we'll do it from now on. So thank you guys. Yeah, I've said it before, but let me say it again. To join my WhatsApp group, just send me a DM. Instead of going to my link, my bio, and then you can't find the link, just send me a DM immediately. And then I will tell you what to do to join the WhatsApp group. Thank you guys. Thank you guys. See you tomorrow, 8 p.m. Nigerian time. Yeah, I've learned that that's 2 p.m. Jamaican time. So today I've learned that it's 2 p.m. Jamaican time. And that's also 6 p.m. Texas time. Sorry, 2 p.m. Texas time, and so on. So see you guys tomorrow. Have a wonderful evening. Adios.